Hello class, Mr. Greg here. I hope you are doing well, and I want to welcome you to our first lesson in, I guess we'll call it Electronics 201. It's the summer classes that I'll be doing online for you to follow along and get better and better with it using the Arduino. And we've got a bigger goal in mind for next spring, and so I need you to really learn how to do these projects because each one's going to build on another, and I've chosen them for a particular reason. So today's project will be using the sonic sensor. So what this does, it sends out a ping out, and then that ping off of an object and come back, and the sensor will detect that. Then the Arduino will measure how long it took that ping to get to wherever it was going and come. And based on that and the speed of sound, you can determine a distance, how long it took the ping to get there and back. It travels at the speed of sound. You divide the time out of it, and you get a distance. And so we're going to learn how to do that today. So I need you to get your sensor out. I need you to get your Uno out, and I need you to get 4 wires out. One of them needs to be a little bit longer, and we're going to hook this up. But before we do that, I'm going to show you the diagram so you can get ready and pause if you want to take a look at this. But it's really a pretty simple hookup. There's only 4 wires that we need. There'll be, of course, power and ground, and then 2 digital inputs, and then we'll do some programming. So I'm going to go ahead and hook that up for you, show you as I go along. The first thing I'm going to do is go ahead and just put the sensor in the breadboard. Now I'm putting it along this line here, and that way it gives me plenty of options to hook the wires in behind it. I'm just going to put it somewhere in the middle like that, so it's perpendicular to the board and facing away from me. And then the first thing I'm going to do is hook up my ground wire. I don't know if you can see that very well, but they're labeled. See if I can get this thing to focus. You can see that they're labeled ground, echo, trig, and I think it's VCC on there. And so my ground wire is obviously going to go to the ground of the Uno. Now I think on the diagram I drew the ground over here, but that was just so it would be easier for you to follow. My next pin is my echo pin, and I'm going to hook that. Let's see, I'm going to hook that into pin number 6. Pin number 6. And then my next pin is the trig pin. Put that in the next slot. I'm going to hook it to pin number 5. And then my final pin is the voltage. So I put that there, and it has to go around to the 5-volt input on the Arduino. And it's that simple. So having done that, I'm going to switch us over to my Arduino Sketch here. I'm going to make this a little bit bigger so you can see it. Let's see how did I do that. I made that too big. Bear with me. All right, so the first thing we need to do, is set up some variables, right? So we had 2 digital pins, 5 and 6, so I guess we should set those up first. So let's see, I had an int, we'll call it trig pin, and we hook that to 5. And then we have an int echo pin, and we hook that to 6. So that sets our pins. I need you to be putting your comments in here. Again, I don't do that as I go through here just because it will slow the video down, but you need to be putting in your comments so that when people see your code, they understand what you're trying to do and they can follow your code. Let's see, the next thing is we're actually going to measure a time, and we need to put that somewhere. And that time could be, you know, a minute, it could be 25.7 seconds. And so rather than use whole numbers, we want to use the in-between numbers. And so we're going to create a float. All right, and I'm going to call that ping time. I'm not going to give it a value because we're going to read that value. And then once we read that value, we're going to take it, divide the time out by the speed of sound, and we need to put that value somewhere. And that's going to be a float also, small f. And I'm going to call that target distance. Target distance. All right. And then we do need to use the speed of sound to get our value. So I'm going to create a float for that. And I looked this up. Call it speed of sound, and that is actually equal to 776.5 miles per hour is the speed of sound. So I've entered that. That looks pretty good. So we're going to go down here into the void setup, and I messed mine up a little bit, so I'm going to fix it. And we have 2 pins. So, well, first thing I'm going to do is turn my serial monitor on because I want to be able to read what I'm measuring. So serial begin. I like 9600. All right, and then we have 2 pins, and so we need 2 pin modes. This should start to become intuitive for you. We've got our trig pin. Let's see, now our trig pin is the pin that is sending something out, right? So it's sending out a ping, and since it's sending it out, then it must be an output. Output. And then we've got pin mode, echo pin, and it's going to receive that pin, that ping, and so that will be an input. It's pretty logical, isn't it? All right, that's pretty straightforward. Now down here to my void loop. Let's think about this. The way this works is we have to create a ping, and so that means we have to turn our sensor on, turn it off, right? Turn it on and turn it off and put some delays in there just to give it a chance to move. And so I'm going to start by turning it off, and so I'm going to do a digital write, just like we did with the LEDs, right? So digital write my trig pin, and I'm going to turn it low. All right, and then I'm going to put a delay in here, delay, and I'm going to be a good programmer and come up here and create an integer for that. We'll call it DT, and I'm just going to do what should I do? Just 10. I mean, I want it to be really just a very short delay. In fact, I'm going to do a new command for us. It's not going to just be a delay, it's going to be a delay in microseconds. So that's just going to briefly give it a second to settle, and then I'm going to send out or turn it high, trig pin high. To get that pulse, I'm going to do my delay in microseconds again, and then I'm going to turn it off. So this creates that ping that we need to measure. All right, so now that we've created a ping, we need to read that ping, and so we created a bucket for that up here, if you remember correctly, called ping time. And so I want to put that information in that bucket. Ping time is equal to, now here's something we haven't done before. To be able to read this sensor, we're going to do a new command, and it's called pulse in. There we go, capital I. And we're reading that off the echo pin. And we want to turn the echo pin on and read it. And so now we have a value in ping time. And then we need to we need to read this value. So, and we need to, let's see, take this, and once we read it, we need to multiply the ping time by the sound, by the speed of sound. So this ping is going out at the speed of sound, bouncing off, coming back, right? We read it, we put it in a bucket called ping time, and then we measure our target distance is equal to the speed of sound, which is a variable that we created earlier, times our ping time. So does that make sense? I hope so. And then we want to be able to read that, so I'm going to serial.print, just going to do it each line, and I'm going to read that target distance. Then I'm just going to give it a little delay, do a regular delay. I'm going to call this, I'll be a good programmer and create a variable there in case my delay is not long enough or too long. And so I'm going to come up here and do an int dt2, and I'm going to make that half a second. I think is what I want to do there. All right, so that looks pretty good. I'm going to move this over here, and I'm going to download this to my Arduino. So plug it in, hit download. Seems to be working pretty well. Alright, it liked it. So I'm going to turn on my serial monitor. I'm going to turn this on where you can see it. Just bear with me 1 second. Is that it? All right, so now I have some values. I see that my sonic sensor is working. I'm going to turn off the auto scroll. I'm getting a value of 677,884. That doesn't make any sense to me. It's a consistent number, but it doesn't mean anything, and I think I know why. And so that's going to require us to do a little bit of math. Yes, oh no, math. And so I'm going to set this aside. I'm going to close this down and turn back on my camera so you can see what I'm doing here. Move this aside and get out a piece of paper. Let's try to understand exactly what is going on with our Alright, so the speed of sound we said was 700, what did we say it was? 776.5. Sorry for shaking there. Miles per hour. Well, our sensor is reading in microseconds. And so when I multiply this by microseconds, whatever it is, my values are not lining up, and therefore I'm getting an error. So we have to do what they call some dimensional analysis, right? And the way we want to do that is, I could do this all in one pretty short effort, but I think one that would be confusing to you, and it is prone to errors for me. And so the first thing I have is this value in microseconds, right? And so I want to get that into seconds. And so the way I do that is I will take our ping time and I will divide that. Let me make sure I do this right. Yes. Is that right? Is that what I want to do? Yes, I'm going to divide that. Actually, I need to draw this better. My ping time, and I need to divide that by 1 million, because micro seconds is a million. So now I have my ping time in seconds. So then the next thing I want to do is divide my ping time, because I need it in hours, right? So I want to divide it by there. I get it in seconds, and then I want to divide it by 60 seconds to get it into minutes, and then I want to divide it by 60 minutes to get it into hours. And so 60 times 60 is 3,600. So now I have my ping time in hours. So let's just go back to the code here and do that. All right, so I'm gonna come up here and I'm gonna go ping time is equal to, well, ping time divided by, what did I say, 1 million, right? 1, 2, 3, 4, 5, 6. All right, 1, 2, 3, 4, 5, 6, 7. All right, so now I'm in seconds. And then I want to take that value, the value of ping time. So we've created a new value for ping time, and it was equal to the ping time that we read before. Ping time, and I want to divide that by 3,600. All right, so now let's download this, upload it, excuse me. Turn on my monitor and let you see what my serial monitor is. Now I'm getting 0 out of this, and that is a problem. I think I understand what that problem is, and that I have created such a small number of distance, because if you remember correctly, we were in miles. Oops. We were in miles per hour, and then we took care of the hour part, but we haven't taken care of the miles part. So if I can get my webcam to work here. So this results in a very, very small number, too small to print out on our serial monitor. And so we need to address this miles part also. And how are we going to do that? Well, we've got this variable called target distance, this bucket, right? And it's measuring miles. And so since my sensor is only really measuring a few inches, I'm getting this really small number in relation to miles. And so what I need to do is take that number and I need to multiply it, because I want to read out in inches. And so there's actually 63,360 inches in a mile. And so if I take that target distance and multiply it by that number, then I should get my value in inches. But there's one thing I didn't think about, is that my ping is measuring the total time. So that's the total time to get to an object like the wall and bounce back. And so that's actually measuring the distance there and back. And so I need to take my target distance, which I didn't write that right, and divide it by 2 also. And then that should get me a pretty accurate measurement. But let's see. So I'm going to get back to our code here. So I'm going to come down here. I've got a measurement of target distance. So I'm going to take that measurement is equal to my target distance above divided by 2, and then I'm going to take that number, target distance, and I'm going to multiply it by 63. What was that number? 360. And that should get us in inches. So let's download this or upload it. Let me turn on my serial monitor here. Turn it on so you can see it. There that is, and then I'm going to actually make this where we can see both of them. All right, so now I'm getting a number that makes sense. So I've got a target. It's this box. And so as I move my target closer, let's see, I'll move this over. It's measuring the distance. Huh. And I wonder how accurate that is. I'm going to put my trusty ruler up here. And that is reading from the end of the barrel. It looks like, and I got a little bit on the end of this thing too. Looks like about 2.66. How about that? And if I move it away, yeah, a little over 4.5. How interesting is that? If I take my box away to the walls, about 15 inches. See what it is to the ceiling. Huh, how about that? How about to the wall across the room? Oh, one thing about this, you got to be flush to whatever you're aiming, or it won't come back. How about that? That is pretty cool. And now that we can read this, there's a lot of possibilities. Not only can we use it for distance measuring, but we also could use it to hook to, let's say, a robot or something, and the robot wouldn't have an idea of how far it was away from an object. And once it got within a few inches of, let's say, the wall, then you could write an if command and tell it to turn around. And so that is pretty neat. So here's your homework. I need you to do this code. I need you to copy and paste it on a Word document. Please don't send me your Arduino, because I have to open it up in Arduino, and a lot of you name your codes the same thing, and that causes an issue. So copy and paste the code showing me that you did it, and then I want you to go back in here and I want you to put values. We know this is in inches, but some casual person may come and look at this and they may not know it in inches. And so I want you to put inches in here for me and make it look neat, and turn that in also on how you, and that should be part of your code, and I'll know if you've done it correctly. So this is lesson 1, and then we'll have lesson 2 out very shortly. Have a great day.